Right, guys, welcome back. Could you all comment your names, please, and I will do a quick register. Cool. All right. So we've got Jay, Kai, Billy, Danny, Nula, Harry, Chloe, Callum, Lucy, Scott, Jake, Elliot, Tristan, George, and Ollie. Cool. Kieran said his internet's broken, so we're just missing Louis and Becky. If you guys are there, give me a shout. If not, hopefully you'll catch this later. So where did we get to the other day? Just put my phone on silent. Cool. All right. I can't remember if we did this or not. Okay, Louis, yes, that's what I'm doing as well. Okay, did we do this question? I've written A1 start here. Is that because this is what to do next, or because we did this but didn't get a chance to go through it? Can you guys comment? Because I don't actually remember. I can always go back and check last week's video. Wednesday's video. What did I say? Cool, right. I think we've got time for one more. We might not be. Okay, yeah, so it looks like we started it. Have you guys all done it then? Are we ready to go through it now, or do you want a couple of minutes to check it? Should we just go through it? Yeah, let's just go through it. I will do a quick starter in a second as well, but we'll go through this. So, it's known from previous records, 15%. So we need to write out the distribution first. Always start with the distribution. So X is binomial distribution with 10 in the sample, and our probability is 0.15. There we go, so that's part A done. Didn't even realise I was doing that. Part B is probability X is at least 3, so greater than or equal to, greater than or equal to 5. And part C is exactly 2. Okay, so we need to bring up the calculator. There we are. Alright, so we are looking greater than or equal to 5. So menu, distribution, stats even on this one. Distribution, binomial. So the first one is cumulative, so BCD. Lower is going to be 5. Remember, it's inclusive. Upper is going to be 10 because that's the maximum number in our set. There are 10 trials. The probability is 0.15. So we should get, oh, it's quite a tiny probability. 0.00987 for that one. And for the second one, probability X equals 2. We can also do this on the calculator. We don't have, let's do both. So without the calculator, it's going to be 10 C2 0.15. Oops, 0.15 squared times 0.85 to the power 8. And we can do that on the calculator as well. So 10C2, C is quite hard to find on the calculator. So 10, let me go option, stat, nope, option, prob, C, so 10C2 times by 0.15 squared times by 0.85 to the power 8. So we should get that as our probability. Let's check though by going to the statistics mode and doing it on the calculator as well. So distribution, binomial. This time it's going to be BP. Oh, hang on. Did I do the right thing last time? We'll check that in a second. So number of trials 10. X this time is, yeah, we did it right last time. X is 2. And lo and behold, we get the same answer. So my answer for this one should be 0.276. Well, let's do 4 decimal places. 5. Cool. Right, has anybody got any questions about that so far? Everyone okay? Everybody confident with these? Okay. So I'd like you guys to try one, just so I can see that this has all gone in from last lecture. So could you all please, as 15 of you logged in, 15 answers please for this one. X is a binomial, 50 trials, 0.4 probability of success. Can you guys find the following? Cool. Alright, could you guys do those then? So I'll give you 10 minutes to do those. Please could comment all 4 though, every single one of you, comment all 4, so that I know that this made some sense. Alright, timer starts now. Cool. All right, the 4 of you have answered. Good job. You've all got the same answers, so that's very hopeful. It'd be good if the rest of you would reply as well, but thank you to those of you who have. So to do these, I'm going to sketch each one, and then we'll solve each one. Oops. There it is, isn't it? Oh, I think it might have deleted that. Yep. Cool, right, I'm just going to write those out again. While I copy these out, could you guys comment what you think the most likely outcome is from this experiment? So to sketch these, the most likely outcome, we times the number by the probability. So 0.4 times 50 is going to be 20. So most likely is 20. And the first question is asking us to find this area here, which is pretty straightforward. We can just type that into the calculator. Yeah, well done, Lucy. So if we bring the calculator up, and we go to NCD, because we're talking about cumulative distribution, or BCD, cumulative distribution. Our lower is going to be 0, our upper is going to be 20, number of trials is 50, and P is 0.4. So I get 0.5610. That's our first one. Second one, greater than or equal to 35. So stuff over there. If I call this one 35, we want to include 35. So on the class whiz calculator, remember that only does less than. So to do this one on the class whiz, you're going to have to do 1 minus the probability x is less than or equal to 34, and that'll work. On the graphical calculator though, I can just type in lower as 35, upper as 50. Did I do that right? That's very unlikely. Yeah. Okay. So we get 0.0, Callum's written it down, 0.0001709. There we go. Okay, next one, less than 22. So let's do another sketch for this. I'm just going to space these out a bit. So less than 22. 22 could be there. We don't want to include the 22, so we want to go from 21 down. So this is the same as probability x is less than or equal to 21. So we put 21 in and get our answer. So lower is 0, upper is 21. So 0.6701, which is what you guys mostly got. Guy, check your question 3 out. I think your question 3's gone wrong there. Yeah, so 0.6701. I reckon you included the 22. Louis, yours doesn't look quite right either. Oh wait, no, sorry, that's right. Yeah. Yeah, have a look at yours as well, Louis. Yeah, that's better. Go, cool. All right, greater than 39. If I sketch it, this is going to be tiny, this one. So if that's 39, we want to not include 39, we want to go from 40. So we're going to do, on the class whiz, we do 1 minus probability x is less than or equal to 39. On the graphical, we're going to use 40 as our lower. So two very different methods there, depending which calculator you're using. So lower 40 and upper 50. There you go. 8.93 to the power 10 to the power minus 9. Not going to draw that because it's so many zeros, but that's what you get. And that'll be the same thing on the other calculator as well. So if I show you guys the other calculator quickly, just so you can see how to do this. Here we go. Distribution, binomial CD, variable. Okay, list we're going to use later, but variable's all we need for this topic. So this only does less than or equal to. What did we want? We wanted, I forgot what the question is now. We wanted greater than 39. So we're going to go 1 minus less than or equal to 39 because we don't want to include it. So x is going to be 39. N is 50.4. So there you go, and you've got to do 1 minus that. So it's going to be 0, 0, 0, 0, 0, 0, 0, 0, 8, 9. Cool. Anyway, so that was where we got to last lecture. Okay, main focus of today is to look at finding the inverse binomial distribution. This is when we know the probability and we want the value. So in other words, we know what this probability equals, and we want to find out what this value here is when we know the probability. Okay, so we're going to go for an example, and the way we do this is using the list mode on the calculators. So, e.g. x is a binomial with 50. We use the same distribution as just now, 15.4. 1. Find the largest k value such that probability x is less than or equal to k is less than 0.05. Right, now we really need to sketch these or we run into some trouble. So I'm going to do a sketch. Don't have to sketch all 50, just sketch a few bars so you have a rough idea what's going on. Okay, and the probability of being less than or equal to this value is less than 0.05. Is that likely or not likely? Do you think k is going to be this side of the most likely value or this side of the most likely value? Have a think, I'll give you guys a minute. Where do you think k is? Is it on the left or is it on the right? So 2 minute quick think about that. Right, what do you guys reckon? Where should it be? Where should K be on this sketch? To the left or to the right? Just going to wait until there's some comments. Yeah. Cool. So Elliot reckons over here. So one of these values here. Anybody else got any opinions? Left as well from Scott, right from Danny. Wait, no. Harry's gone for right. Left for Louis, maybe. Okay, this is quite hard. You've got to be able to identify this before you can do these questions. So let me read this out. The probability of getting less than this value is less than 0.005. So that's not very likely, yeah? That's 5%. So the probability of being less than this value is less than 5%. So it's very unlikely it will be less than this K value. So K has to be down here because the shaded probability, let's get rid of these arrows. So if I put K here, this is telling me that all the shaded probability is less than 0.05. It's very unlikely, which is what we'd expect for having K so far down. So that says K should be on the left. Make sure you guys understand that. If you don't, please comment and say, I don't get it, explain it better, because that's really key to being able to do these questions. So it's not very likely you're going to choose a value at random that's less than K, because there are all these values more than K. So K's got to be down this side of somewhere. All right, so the way we're going to do this is with the list mode, and we're basically going to type in a load of values, all the probabilities, and find the first one or the last one before the probability goes above 0.05. So this, because we said already the most likely outcome is 20, we'd probably start to the left of 20, so maybe going from 16 downwards, work out all those values, and we're going to find when the probabilities start going below 0.05. So I'll show you this on the graphical calculator, but it is a very similar method on the ClassWiz as well. So there's the calculator. Right, so we're going to go exit, distribution, binomial, cumulative, and now we're going to go list. Okay, and just remember it's actually a bit harder to do this on the graphical. I'm going to show you on the other calculator first because it makes more sense. The graphical is great for it as well, but inputting it makes more sense on the standard calculator. So yeah, remember we're trying to find the first probability less than 0.05. We're looking at the lower region. So can you guys, hopefully you can see that. So we're going to go back to the menu, distribution, binomial CD, and now we're going to go list. So look how dirty my calculator is. In the X thing here, remember the most likely outcome was 20. So we're going to go less than 20. I'm going to go from, I think, 16 down. This is going to be hard to type without being able to see the calculator. So 16, oh god, 15, 14, 13, 12. Right, I'm going to 12 because I've hit equals, but we might need to do more. So type in your N and your P, which will be the same. Should be the same. Give it a second because we typed in quite a lot. And then it started doing them. Okay, so this has worked out really well. So can you guys see? I'm just going to take a photo of this actually. Click. All that dust, gross. Okay, so, all right, what we've done then, we wanted the first value where the probability dropped below 0.05. So the first value, we want the largest k value when the probability is less than 0.05. There's 0.05, so the first value where the probability is less than that is 13. So that tells me that k is 13 for this question. Right, we're going to do the same thing on the class whiz, because it's a little bit different. So same thing on the graphical, because it's slightly different. So we go list, but we don't have that nice option on this one where all we do is you just type in x and it gives you p. Here we've got lower list and upper list, so it's a little bit more confusing. But that will actually help later on. So we're going to go lower list, list 1, upper list, list 2. We actually need to go in and edit these lists now though. So if I type in list, oh, no, don't do that. Cool. Alright, so we need to go into list 1. So I'm going to go onto list 1 and hit. Okay, I'm going to leave there. I'm going to go to statistics. Exit this a second, you'll get to the list. So these are where the lists are that we're talking about. So it wants a lower and an upper. So my lower, because we're looking at the tail to the left, my lower for all of this is going to be 0. So I'm going to type in a load of zeros. I'm then going to type in my x values. So what did we start with? 19, 18, 17, 16, 15, 14, 13, 12, 11. So there's my data, all in the table now. Now we go distribution, binomial, BCD, list, list 1, list 2, execute. Okay, what's a bit annoying is it's given me the probabilities, but I can't see how they line up in anything. So I'm going to go save res, and I'm going to put it in list 3, and hopefully that should put those in list 3. Yeah, there we are. So you can now see my probabilities have lined up, and they're there in list 3. So again, we want the first probability that's less than 5%, which is this one, which is 13. So you can see, kind of comparing these two, you got the same probabilities, but you need to tell this. This one's a bit pickier with how you input what it wants. This one you just type the numbers in, hit equals, and done. This one you've got to put lower values in, upper values in, and then tell it to save your list 3 residuals, they're called, into list 3. Right, so that's how you do a less than one. I want you guys to try and do a different one. So I'm going to hide the calculator a sec. Get rid of this picture. So don't forget to do a sketch. Right, so you guys are going to find the smallest value of R such that probability x is greater than R is less than 0.01. So I will give you 3 minutes to have a think about that. So do a sketch, see if you can solve it. Depending which if you've got both calculators, you're welcome to do it using both calculators. Dimension error, okay. If you've got a dimension error, Callum, if I just bring the calculator back up for us on timer. If you've got a dimension error, it's because you've typed in, where's my calculator? You've typed in too many values in list. What you've done is something like this. So if I go back, you've done 10 values in list 1 and only 9 values in list 2, so it doesn't understand. So if you've done that, just go to the extra 0, delete it. And when you need to do this, you need to tell it to put the answers in list 3. So BCD, you need to say save my answers, save results. That stands for save results in list 3. It'll only do that if there's no dimension error. So if you type that in, okay, fine, but you need to have the same number of things in list 1 and list 2 for it to work. Alright, so timer starts now. Right. Reason list 1 needs to be 0 is because you are finding the probabilities. If I do a quick sketch, actually, can I give me 1 sec, Harry? I'll try and answer that question with GeoGebra. Where is GeoGebra? That's weird. I had it. What? It was here the other day. GeoGebra. Okay, let's try and get this working. Okay, so here's GeoGebra. I'm just going to go into stats mode. I haven't actually tried this yet, so bear with me. Cool, can you guys see that? Yeah, you can, cool. Right, so I'm going to get a binomial distribution up. There you go, let's make it hard. So I'm going to put 50 in, and my probability was 0.4, wasn't it? So this is what my distribution looks like. We're trying to find if I... we were looking for inverse. I can't actually do inverse right now, but whatever. We're trying to find the left-hand tail, yeah? So we're trying to look for 0.05, was it? So there we go. So what you guys are doing is you're asking the calculator. I don't need to wait. Should I? Okay. What you're doing is you're trying to find whatever this value here is. The calculator needs this calculator. All you do is you put in this value, and it knows it goes to 0. The graphical calculator is a bit smarter. The graphical calculator can do it between any 2 values on the whole thing. So you need to tell the calculator, I'm going from 15 to 0, which is the lowest possible value, because we're talking about a number of things happening. Binomial distributions are always to do with the number of items, number of trials, number of tests, whatever. It's always going to have 0 as its lowest. So we needed to tell it the lowest value is 0, and then each other value is all these values you're trying here. Does that make sense, Harry? I think that does. So we wanted to try and find the smallest R value such that R was less than 1. If I bring back GeoGebra, I did type that in. I wanted P to be 0.01. So it looks like it's going to be 11 or 12, and actually GeoGebra is pretty useful in that it's done the calculations for me up here. So we can use this as well as the calculator. So we wanted the probability to be less than 0.01. So if I look through the table to find 0.01, there we go. So it looks like 12 is going to be my answer. Is 12 what you guys got for the answer as well? We can check it on the other calculator as well. But I will, let's close GeoGebra. So, as you saw in the sketch, oh wait, we're going greater than now, so that's completely wrong. You wouldn't have got 12. Let's do that again. Okay, so we were looking up the upper end of this, and the probability there was 0.11. So there we go. It looks like it's going to be 33. If I look through the list, 0.01 will probably be less than that. So, oops, 33. I imagine you guys got. E means times 10 to the minus something, so it means it's tiny. So if you look at the list up here, this means 5.6 times 10 to the minus 3, so it's a standard form kind of thing. So yeah, I think we're going to get 33 from what GeoGebra tells me there. So yeah, that's the idea. We're sketching it. Because it was greater than this time, the probability of being more than this is tiny. We know that it must be somewhere around here. So it's got to be one of our upper values. So if we go from 20 upwards, maybe 23 upwards. So if I go into my calculator up here, and I'm going to type in 23 is my upper. Sorry, 23, 24, 25, 26, 27, 28, 29, 30, 31. If we got to 31, see what happens. My upper value is going to be 50 in each case. Because the most number of trials we had are 50, so the most number of wins we could get is 50. Okay, so if we then go to distribution, binomial NCD, list 1, list 2, number of trials 50 and 40 is still true. Save results to list 3, execute. Here we go. So I'm going to go back, go into my table. Alright, so we want to find when the probability here is less than 0.1. So it looks like it's going to be this one, 29. Yeah, so 28 is too much. 29 is our first one where the probability is less than 0.1. So R is going to be 21. We could always check that. We could go kind of back to the distribution like we did before. Just going to move myself back down. So we could go dist binomial PCD. We could type in go to variable. Lower could be 21. Upper is going to be 50. We could work out what this probability is. So, wait, is that right? Wait, why do we get 21? Why does I think I've done something very wrong here. Let me just change this one around. List 1, list 2. Sorry, 29 wasn't it? Where did I get 21 from? 29. Okay, let's get back to distribution. Binomial BCD. So just to check it, if I go back to variable, type 29 in, this should be the first value. Yeah, so first value just inside of 0.1. Okay, any questions, guys? Sorry, that was a little bit confusing with the 21. Should we do another one of these? So we'll try to do 4 of these. X is a binomial with 30.3. Find the smallest a such that probability X is greater than A . So if you guys could try these two, we'll see how you get on with those. So I'm just going to go with the calculator. So sketch it, similar to the ones we just did. See if you guys can do these on the calculator. So I'll give you 6 minutes to do those. Cool. Right, we're going to go through these. I reckon I should have given you guys a bit more, some more examples, and I do think I might have made a mistake here because I think I used less than or equals to there. Yeah, that was a bit sloppy of me there. And that's why I said be careful of less than or equal to. So, okay, we want to find the smallest A value, so it's the probability A is greater than this is less than 0.05. So I'm going to draw in some boxes. So the most likely outcome is 0.3 times 30, which is going to be 9. So we'll label this one here. That can be 9. Okay, so we want to find the smallest A value so that being greater than A is unlikely. So A is going to be up this side of our distribution. So I'm going to draw a table out. We'll come back to this one in a second. So I'm going to draw a table for all the values greater than 9. Basically, I'll skip a couple, maybe start at 12. So greater than 12. If we just do greater, we'll just do these to start with. So to do x is greater than 12 on the class whiz calculator, obviously this can't do more than. So to do greater than 12, we're going to do 1 minus the probability. If we think about this bar here being 12, this would be 11. To do greater than 12, we're going to do 1 minus all this stuff. So we're going to do 1 minus less than or equal to 11. So let's write that in up here. So this is 1 minus probability x is less than or equal to 11. For 13, it's going to be, sorry, that should be 12 there. For 13, 1 minus the probability x is less than or equal to 13. 1 minus the probability x is less than or equal to 14. And so on and so forth. Okay, so we're going to try and find these. On your graphical calculator, this is a lot easier. That's why I'm spending a bit more time on these ones. So, in my table on my graphical calculator, I'm going to type in 12, 13, 14, 15, 16, 17, maybe 18 as well. I'm going to put in my, so if I could show you guys that. So, put those values in, all the way down to 18. I'm then going to type in 30 and 0.3 by distribution, hit equals, and we get all these probabilities. So I'm just going to take a photo of those. Obviously there's more that aren't on the screen, but I can show you what we're going to do with those ones. So if I make that a bit smaller, and drop that in here. So we need to do 1 minus each of these values in order to fill up the column so that we can find the first one where this is true. So for that to be true, we'll fill out this column here, which is 1 minus that, and we'll have a look for the first one that's less than 0.05. So we need to do 1 minus each of these. Now there's a really quick, easy way to do 1 subtract another number. The rule is we're going to make each of these decimals up to 9 and then make the last one up to 10, and it's a really quick way of subtracting these from 1. So for the first one, it's going to be 0.0845. So we're going to write that up here. Oops, with the pen, not the eraser. 0.0845. Cool. Second one, 0.0405. So it already looks like we found our answer. I'll do the rest just to show you guys this method though. Next one, 0.017. Yeah, 0.017. 0.0064. Etc, etc, etc. So we look at our table, which is the first value to be less than 0.05? This one is, and that is 13. So A now should be 13. So that's how I do this on the class whiz calculator. To do this on the graphical, it's slightly different, because we don't need to do all this 1 minus stuff. So on the graphical calculator, I'll do a similar table just so you guys can see what's going on. So to do greater than 12 on the graphical calculator, we're going to do lower is 12. Sorry, no, not. Greater than 12, we're going to do lower is 13. Upper is 30. For greater than 13, our lower is going to be 14. Upper is going to be 30. Greater than 14, lower is going to be 15. Upper is 30. Etc, etc, etc. So I bring the calculator back up. Where's it gone? Cool. So lower, we said was. I need to go to the list, don't I? Okay, list. Exit. So if I delete all this stuff. There you go. So we said lower 13, 14, 15. Cool. And the upper for each of these is going to be 30. So let me go to distribution, binomial, PCD. Oops, changed number of trials to 30, probability to 0.3. Oops, need to put the other save results to list 3. Hit equals, back, get to the table. And again, we can, if I just move the calculator down, we find that for greater than 12, the probability is 0.08. Greater than 13, the probability is 0.04. So that's the one we want, is when we're greater than 13. We can write the probabilities there if you want to have the table in your notes as well. So 0.0844, and then 0.04, and then 0.169. So again, 13 is our answer for that. Does that make a little bit more sense, guys? Please comment if you need any help, because once you've got these, it's good, but it is new and it is that use of technology as well that students can find difficult at first. So I'm going to put back up that second part of this question. I'll give you guys a couple more minutes to solve it, and then we'll look at a couple more examples before the end. Cool, right, could you guys try that? A couple more minutes just to try and do that one. Callum, I don't really understand what you mean by that question there. Why is it 13? And the probability is greater than 0.3. I'll leave this up, I'll rewind and have a quick look, see if I can get to the bottom of that. The probability column isn't. You were looking at this bit. Yeah? The probability is less than. Yeah? But the value is more than, is what you're looking at just now. So you're getting your probability and your values mixed up. It's the probability of the stuff in brackets is less than that. The number on the end is the probability. The thing in the brackets is the value. So in this one, for example, it's like, imagine you're playing a game 30 times. And the probability of winning the game is 0.3, so not very likely. Find the greatest number of wins you're going to get, such that the probability of winning less than that number of times is less than 0.15. So sketch it, look for where B is on your distribution, and then look for all the values to try and find the first value where it's less than the value you're after. Because we wanted the probability to be less than 0.05. If I yeah. Let me just paste that in. Yeah, this is what we were doing. That's what we were doing earlier. Yeah. So it's the probability of being greater than A is less than 0.05. So you wanted the first value where the probability was less than 0.05. So 13. Okay, so now I see what you're saying. Okay, it wasn't 13 though, that's the problem. It was. Let's copy this when the table's filled in. I delete that one now. No, keep that. There we go. That's what we were doing just now, this question here. Yeah. So these are the probabilities below me now, yeah? 0.84, 0.04, 0.01. We wanted the first one where the probability is less than 0.5, so that's got to be this one, yeah? Now, that one correlates to, or that one kind of matches up with what you're saying, 14, yeah? And you're saying this 13 is more than. But this 13 doesn't mean anything. We're looking for this column we want to find. This is our value. We're saying greater than 13. How do we find greater than 13? On the graphical calculator, you type in 14, which gives you this probability. So the answer is 13, despite it coming from this one where we typed in 14. Does that make sense now? So you're saying, why is it 13 when the probability is greater? This probability is greater, yeah, and that was from 13, but that relates to greater than 12. So greater than 12 was no good. We wanted greater than 13 for it to have the right probability. These are the values. This is how we find those values on our calculator. This is the probability of these values. This was just how you type it in, because the calculator will only do greater than or equal to. So we're saying to do greater than 13, that means greater than or equal to 14, which matches up here. So that's why. Hopefully that explains that a bit better. It's all to do with the calculators. If you always want to do this on the class whiz, sometimes that's easier if you just always do it on this topic. But if you want to do it on the graphical, you've got to do the lower and higher, and you've got to understand what it's actually kind of finding. Alright, so for this one, find the greatest value b such that probability of less than b is less than 0.015. So probability of being less than this value is tiny. So I know that b has got to be down this side, so I'm going to put b here. Our average value was 9, so I propose we go 8, 7, 6, 5, 4, 3, 2. To go less than 8 though, you need to go, so less than 8. To do that on the calculator, you need to do less than or equal to 7. Less than 7 is going to be less than or equal to 6. So this is calc. Value, calc, prop. So less than 7 is less than or equal to 6. Less than 6 is less than or equal to 5. Less than 5 is less than or equal to 4. 3, 2, 1. So then we can find those values on the calculator. You can either do it on the Casio. So if you type in on the Casio 7, 6, 5, 4, 3, 2, 1, put in the probabilities, straight away you'll get your probabilities. You can see that. To do it on the graphical calculator, again it's slightly more tricky. Our lower list is now going to be 0 because we're at the bottom of the distribution. And our upper list is going to be 7, 6, 5, 4, 3, 2, 1. So let me go distribution, binomial, BCD, list 1, list 2, 30.3, save residuals to list 3, and calculate. So if we go back into our list, there's our probabilities. We want to find the greatest one that has a value less than 0.15. So if you look here straight away, 6 is slightly more than 0.15, 5 is slightly less than, so this is what we want. If I just transfer these into this table, it'll become a bit clearer. So greater than 7 was, off the screen, 0.218. Sorry, 0.2813. Less than 6, 0.1595. Less than 5, 0.0765. And so on and so forth. So, we want the first value, the greatest value of b, so the greatest value of b, such that probability is less than 0.15. More than 1.15, more than 0.15, this is less than. So this is a value of less than 6, so b equals 6. We found it using 5 on the calculator, but that doesn't correspond to anything. That's just how you find less than 6. So b equals 6. Right, has anybody got any questions? I think we'll do 2 more of these before the end. We might end up having to do these as starters for next week, but we'll do 2 more of these. So I'll start clearing the screen. Cool. All right, so there's 4 there, basically covering every different eventuality. Could you guys try and find S, T, U, and V? We'll start them now. I might write the answers as well, and then we'll go through it on Monday morning. So I'll put a timer on now just for the end of the lecture, so that's 7 minutes. See if you can get them all done now, but we will go through this next time.
Cool. All right, all the answers there, guys. I will leave this one with you to have a think about over the weekend. Watch this video back again if you need to. Do sketches, and we'll go through these on Monday morning. We've got to be quite rapid next week, so if you could all go over this, and if you're still stuck on it at all, let me know before Monday morning, and I'll try and arrange a time. You can go over it again. But watch the video as many times as you like. Email me if you need any more. Make sure assignments are up to date. Next week, I'm going to be going over everything to be done. And make sure those of you that do need to redo the test are revising, because that will be, I think, the week after half term. It'll be either the first week or the second week after half term. All right, cheers, guys. Have a nice weekend. Thank you.